Welcome to a demo of Parasoft C++ test solution, focusing on static analysis and code coverage. My name is Charles Oxreader, and I'll be taking you through the demo today. Before we get into the actual demonstration today, I do have a few slides to go over, mainly to provide context. From there, we'll hop into the demonstration. We'll start with our reporting and analytics solution, which will be of particular interest to stakeholders, people like team leads, architects, and managers. Then we'll get into what the life of a developer will look like performing static analysis and gathering code coverage. Finally, we'll conclude the demonstration with some closing thoughts. Parasoft's mission is simple, and that is to provide automated testing solutions and expertise that empower organizations to expedite delivery of safe and reliable software. Parasoft provides a whole range of products that assist in automated testing, including UI/API microservice architectures, DevSecOps, and embedded systems. Today, we'll be primarily focused on a reporting and analytics solution in conjunction with C and C++ test. Parasoft has many points of integration into your software development lifecycle. The two primary integrations are within the developer's environment and your CI/CD pipelines. A developer will use Parasoft C, C++ test plugin into their IDE, or they could use a command line to perform local static analysis, unit testing, and code coverage. Once a developer is satisfied their code is clean and fully tested, a merge or pull request is executed, which will kick off a pipeline run where Parasoft will validate those changes. The results of that validation process are then uploaded to our reporting and analytics solution to show stakeholders how the quality of the code is changing, hopefully for the better. At any point, a developer can pull the latest results from our reporting and analytics solution to triage and resolve any issues reported by the pipeline run, all within their IDE of choice. And finally, once a project is getting close to a release, our reporting and analytics solution can take the latest testing data to create up-to-date compliance documents that can be used for various compliance standards. For the demonstration, I will be showing you static analysis in action, namely MISRA C 2025. Parasoft C, C++ test solution provides an excess of 5,000 rules for you to choose from. We also have many compliance rule sets to choose from, those which have a safety critical focus like AutoZAR, MISRA, and those that have a security focus like OWASP or CertC. Of those 5,000 plus rules, we can break them down into three different categories: pattern-based analysis, data flow analysis, and metrics. Pattern-based analysis are very simple rules that generally force best practices for the developers to follow. These best practices can be something as simple as naming conventions all the way to always checking the return value of a function call. Our data flow analysis rules, on the other hand, focus on finding real bugs in your code. It does this by symbolically executing your code and playing a what-if game to see where and if we can find problems with your code. An example of this could be passing a null pointer to a function call and following the call graph all the way down to see if there's ever an instance where that pointer is dereferenced. And if we can find a situation where this occurs, we can report this as a violation and provide a stack trace of how we got there. And finally, we would provide metrics analysis rules that will give you valuable insight into how well your code has been written. This can be in the context of C or C++, and is great for finding areas in your code that need to be refactored or could potentially be dangerous. Parasoft C, C++ test solution allows you to collect code coverage through three main ways, either through unit testing, that can be through Parasoft's unit testing framework, it can be through other unit testing frameworks, or it could be through integration system or QA tests. As far as Parasoft's unit testing framework is concerned, we support C and C++. We do have automatic generation of unit tests, which can save you a considerable amount of time. And we also have a Stubbing framework that we'll get into in a little bit. And then finally, it is TÜV certified. As far as other unit test frameworks are concerned, such as Google Test, Catch2, or a homegrown framework, some advantages there is it's not vendor locked. It may have extensive mocking capabilities, but unfortunately, these frameworks aren't certified and they don't have any auto-generation. I say that these frameworks are not certified and do not have auto-generation of unit tests yet because we are in the process of providing both of these for Google tests in a future release of C, C++ test. And finally, just like unit testing, Parasoft can instrument your code. It doesn't have to be a unit testing framework. It could just be the application itself. And we can use this to gather code coverage. And that could be during your integration system or QA tests. Depending upon your code coverage needs, we do have lots of different available metrics, and that can go anywhere from line all the way to MCDC. Parasoft C++ test allows you to collect code coverage either on your host or in an embedded system. So depending upon the type of application you have, we can help you out in either scenario. For host-based testing, this is usually the same platform and architecture where the development is performed. The native compiler is used, and any kind of coverage results are usually stored locally on your file system. When it comes to embedded system or on-target testing, usually it's a different platform and architecture than where the development is actually done. You're using a cross-compiler, and as a result, we have a few extra considerations. One, RAM and flash availability becomes important. We need to make sure we have enough space. How the coverage results are communicated back to the host so that we can analyze the code coverage. And finally, if there's an RTOS in use. As with both of these, Parasoft requires the compiler to be supported, and the code must be able to be compiled or linked today with the compiler that you're targeting. While Parasoft's unit testing framework isn't required for us to gather code coverage, you may consider Parasoft's unit testing framework in the event you're looking for auto-generation of unit tests because you don't have any unit testing framework today, or you need some sort of TUV certification or a qualification kit. In order to use Parasoft's unit testing framework, again, the code must compile and link for the target platform, and we must support the compiler. As I mentioned, for creating unit tests, we have the capability of automatically generating those unit tests. We can create unit tests that test boundary conditions, and we can seed functions with meaningful values. As far as manual creation is concerned, we have a wizard, a graphical wizard that will allow you to create unit tests. You can duplicate existing and modify existing tests. Our unit testing framework is in C and C++, so it's very easy to make modifications as needed. We have a stubbing framework that is available that allows you to control the behavior of individual functions and methods, and you can control this on a unit test by unit test basis. We also provide the capability of scoping, which utilizes stubbing in order to control the context in which your unit test runs. We can have a pure unit test in which the function does not access any other functions outside of the source file, or we can open that up a little bit and give you integration level testing and allow a function under test to actually call outside of the source file. This is our reporting and analytics solution, which allows stakeholders to track progress of your quality journey over time. This can be in the context of static analysis, code coverage, or unit testing results. And furthermore, we have the capability here to show not only dashboards in the context of compliance, but also generate those compliance artifacts that you may need for ISO 26262, DL 178, etc. What we're looking at here is a simple static analysis dashboard that just shows me how we're doing against this particular project with regards to static analysis violations. This dashboard is comprised of a variety of widgets that can be completely customized. Each widget can be customized, or you can add or remove widgets that you want to look at. Most of these widgets are drillable, so I can get more details as needed. So if, for example, I wanted to see the severity 1 violations, I can click on that, and I can see all of the severity 1 violations as well as the code in which it occurred. From here, I can make assignments to whoever I think should own this particular defect. I could also link this back to Jira or other bug tracking software that I use in order to create those defects in that bug tracking system. In addition to static analysis dashboards, you can create a code coverage dashboard, which will show you how you're doing with your overall code coverage metrics. It can show you how you're doing with your functional tests or unit tests or any other types of tests. And you can see how that is progressing over time. We have a metrics dashboard that provides all kinds of data about the overall quality of your code. This can be in the context of C or C++ code. It can give you things like cyclomatic complexity, basic measurements about number of lines of code in a function or in a source file, or even C++ object-oriented metrics like coupling or cohesion. This is a great dashboard to identify areas that need to be refactored or that need your attention because they are of poor quality. All of the dashboards I've shown you so far have been focused on individual projects, or at least the data associated with those individual projects. We can roll up all of those projects into a single portfolio dashboard that can show you the same types of data that we've seen so far: static analysis violations, how well your unit tests or other tests are performing, and what your code coverage percentages are. In addition to that, this portfolio dashboard can show you how you're doing against various compliance standards like OWASP or MISRA or Cert C. And this takes us to our compliance dashboards. So if safety or security is a compliance requirement that you have, these dashboards are great in giving you insight as to where you are in that compliance journey. Most importantly, once you've gotten your code base to a point where you are confident in the overall quality and you feel that it's met all of the requirements of whatever compliance standard you're targeting, if you needed to generate those artifacts that are necessary to prove compliance, we provide that with widgets within the dashboard. With just a few clicks, I can download my compliance artifact, in this case, my MISRA compliance report. And this compliance report contains everything you need in order to show your compliance with MISRA. Now that we've seen our reporting and analytics solution, let's switch over to the developer view and see what the day in life of a developer will look like performing static analysis, code coverage, and unit testing. Here I have a simple Eclipse-based project. Now Eclipse is one of the many IDEs that we integrate into, and our integration is very simple. We have a Parasoft menu item here. We have a few shortcut icons that you can utilize, and we also have a context menu that allows you to execute Parasoft commands from. So first things first, imagine I'm a developer and I've just come in to start my day, and I want to get the violations that were reported by the pipeline run the night before. I don't want to run analysis locally because that may be somewhat time consuming. So all I need to do is download the violations that were found. I'll sort these by severity so I know which ones to focus on first, and then I can go through and triage each one of these individually. Ideally, I haven't introduced any new violations, so the number of violations that I would have gotten from my pipeline run would be 0. However, as you're developing new code, the developer is likely to introduce new static analysis violations. And so it's important for the developer to always run static analysis locally, especially on the source files that they've modified. When running static analysis with Parasoft, it's as simple as selecting the file or files that you want to analyze or the entire project. For this demonstration, we're going to run MISRA C 2025, which is the latest and greatest version of MISRA C. I chose to run a static analysis against the entire project, and once that's completed, I see that I have 209 violations. And all I need to do is go back to my quality task to see which violations I'd like to resolve. Here I have them sorted by severity like I did from the pipeline run. And in order to fix any of these, it's as simple as double-clicking on them and going to the line and making the appropriate fix. From here, a developer will likely run into 2 different issues. One is I don't understand what this particular violation is trying to tell me. Or 2, I know what this means and I don't think we should be reporting it as an issue. In the first case, all you need to do is right-click on the violation and you can see the documentation. And within our documentation, you can see that we have examples and how to repair it. And if you want any additional information, we have plenty of references and where to get that information. The second scenario a developer will likely run into is that they've decided that while they have looked at this violation and they understand exactly what's going on, they've decided, probably after reviewing with some of their peers, that this in fact is not something that they want to fix. It could be because it would be risky to fix it. It could be that after extensive review, it has been decided that it's not important to resolve. And so all we need to do in order to make this issue go away, so to speak, is to suppress this task. Okay, we're going to do this in source code, and we'll provide a reason. And we'll say that this has been reviewed and it's okay to suppress. And once I do that, we'll see that the violation disappears and a comment is added to our source code. Okay, this Parasoft suppress keyword indicates that this is a suppression, and it identifies the exact rule that needs to be suppressed and the message that's associated with. The very cool thing about this is that any of these suppressions will get pulled into your compliance reports that I showed you in your reporting and analytics solution that we provide. So that MISRA C report, this will be pulled into that report and labeled as a deviation, along with the comments associated with it and the author, which would be me in this case, that's associated with Git. There are lots of other ways to do suppressions. They don't have to be on the exact same line. We could do the suppression on the line before and declare that the next line is where the suppression needs to occur. We could suppress blocks of code and say, hey, ignore this particular rule for an entire block of code, or even an entire file. If you recall the various categories of static analysis rules that we have, most of these are pattern-based analysis rules. These are just going to be best practices, or based on the compliance, in this case, MISRA C, are just best practices and what they think is necessary in order to write safe code. With that said, MISRA C does include some rules that are actual data flow analysis rules. And these can be easily identified by the ones that have this arrow that next to them that show you the actual stack trace. Okay, so in this case, we have an instance where a value, in this case the record, could potentially be null. And so here's the stack trace. It's a simple, only 2-line stack trace, so it's not very complicated. This could span multiple files. But in this case, the record could be null, but memset is called regardless. So this could be a very bad situation and cause a seg fault. We have another violation here where we have an array that could be potentially accessed out of bounds. And it provides us with the context of -1. So this is very easy to see, either following through the stack trace, or you can imagine that if this value is called with a value of 0, well, IDX -1 is going to be -1, and this array is going to be indexed at -1, which is going to be a bad situation. While I just showed you MISRA C 2025, I would like to show that we have a variety of test configurations that are available to you out of the box. So if it comes to various compliance packs, if you need security, we have CWE, OWASP, SEI Cert C, etc. If it comes to safety, we have lots of different versions of MISRA. We have AutoZAR, as well as high integrity C++. We have some configurations that are targeting the aerospace industry, like Joint Strike Fighter. And we have some rules that are recommended for FDA. Now, these are just static analysis test configurations. We have configurations that target various embedded systems if we're talking about unit testing or code coverage, which we'll get into next. And we have also several other configurations that target various other static analysis standards. Now that we've seen static analysis in action, let's shift over to code coverage and unit testing. To start, we're going to focus on code coverage with the application itself. This particular application is nothing more than a console application that I can execute on the command line, and it won't do much other than do a few things and then promptly exit. In order to gather code coverage, let's say if I'm a tester or I'm doing some sort of manual tests, I would just want to test the application and make sure that it behaves the way we intend it to behave. As such, Parasoft can instrument that code, and then while the application is under test, we can gather code coverage to see how well those tests are actually being executed. So before I actually instrument and run this application, I'm going to go ahead and clear out my violations from static analysis. And I'm going to go ahead and instrument and execute this application to gather code coverage. And as you can see, the application has been executed and we have code coverage results. Please note that we have not done any unit testing at this point. This is just the application running in its normal environment. This could be on a host or it could be on an embedded system. The green lines here indicate that the code was covered, and if it's red, it indicates that it was not covered. If we switch over to our quality test to see what's going on here, we can see that there are also some memory violations that occurred while we executed this application. Interestingly enough, the static analysis violation that we looked at earlier actually occurred during the execution of the application. So we did, in fact, execute this function by calling it with 0. This is during the normal running of the application, and it actually had this problem. So our static analysis caught this problem before we ever executed it. In addition, we found another situation where a pointer was freed that was null. And so these are two runtime violations that we reported in addition to gathering the code coverage. We can also see the code coverage metrics for this application, and we can break this down by source file, or we can drill in and look at individual functions to see how much code coverage we've gotten. As you can see with standard in-out.c, we have 100%. We have fairly good code coverage with timer.c and driver.c, but we didn't get any code coverage with clock.c. And the metrics that we're looking at here are line coverage. I could change this to look at other types of code coverage. For instance, if I wanted to see statement coverage, we'll see that we don't have quite the same amount of code coverage, but it's very similar. And we also have other types of metrics that are available that you can view in the IDE here. And this is a great way to get an idea of how well your application is being tested from a quality assurance perspective or a system level test perspective. From here, you can take this information and use this to identify areas that need to be unit testing. So for instance, we have pretty good code coverage with this particular source file. We don't need to write any unit tests for this section. However, we might need to write some unit tests for driver.c and timer.c in order to drive the code coverage higher. And then finally with clock.c, obviously we have some work to do. One of the advantages of using Parasoft C, C++ test is the unit testing framework that we provide and its ability to automatically generate unit tests. And so that's what I'm going to do next, is to see if we can drive this code coverage a little bit higher. And just like unit tests, I just need to select what I want to generate unit tests for. So in this case, I'm going to select the entire project, drop this down, and click on Generate Unit Tests. And you'll notice that a test folder was generated and a test suite was generated for each one of the source files. Once the tests have been generated, all I need to do is select my project, in this case, since I want to execute all of the tests that were generated, and run my unit tests. And from here, you can see that there are quite a few tests are reported, and there is some work that we still need to do. When we generate unit tests, we don't know what the return value of any function under test is supposed to have. And as a result, that's one additional step that the developer has to take in order to confirm that the unit test is behaving the way it's supposed to. In addition, when we automatically generate unit tests, it's quite common that we're going to call a function in such a way that causes a segmentation fault. And while we're calling the function in a way that causes a segmentation fault, it's also a great opportunity for a developer to take a look at this function and see, is it really behaving the way it's supposed to? If it's possible to call a function with bad values and have it generate a segmentation fault, it's probably because the function isn't checking its inputs. While it may be true that no function will ever call the function under test with those specific inputs today, it doesn't mean that somebody won't write code tomorrow that does. So this will highlight functions that may need to be reviewed as far as whether or not they're checking their inputs or not. So as I mentioned, one of the things a developer will need to do is validate the outcomes or the values returned by the functions that were generated. So I'm going to scroll down here and find some instances. And so when we generate these unit tests, notice it's plain C, or it will be in C++ code if the code is C++. We just report the values of the function under test, either the global values that it's dependent upon or the return value. In this case, there is no return value. And this is for the developer to validate and make a decision, is this the proper state of the system at the end of calling add timer record? And so if I were to accept this as a valid outcome, notice that it is changed to an assertion. And from here on out, if this particular value is not 100 in this particular scenario, in this unit test case, it will be flagged as a unit test failure. For the sake of the demo, I'm going to go ahead and select all of these outcomes, and I am going to verify all of them, and now everything is going to be changed to an assertion. If I'm dealing with legacy code, accepting all of the outcomes may be a viable strategy. Since the code is well known, its behavior is known, and any test that we generate, the return values will be as expected. And by doing this, I can create a regression suite relatively quickly. Now that I've run my unit tests and I've verified the outcomes of the actual return values, let's take a look at the coverage results. If you recall before, our line coverage says 69% and clock.c had 0% coverage. Now we're at an overall 88% coverage, and most of the code is covered at this point. And we haven't written a single line of code, which is really cool. The other thing that occurred here is that the code coverage from our application run and the code coverage from our unit tests were merged together to give me this 88% view. And this is a great feature of Parasoft C, C++ test, in that I can merge coverage results from many different runs or many different types of runs. So if I had an application level test and I wanted to gather the code coverage there, and then I wanted to run my unit tests or any other tests, I could take all of the code coverage results, merge them together, and get a single code coverage report that could show a very high level of code coverage, if not 100%. Now that we've seen code coverage be generated through the unit test, let's take a quick look and see what we do when we generate unit tests. So what I'd like to do is focus on a very simple function. And we're going to focus on validate size. It receives an integer and it returns an integer. And we do a simple comparison against buff size, which in this case happens to be 100. Okay? If size is less than 100, we will return 1. Otherwise, we will return 0. So the question is, how would we generate code to unit test this? So I can go to my test case explorer, and I'm going to look in this particular test suite, and I'm going to go down to validate size. You can see that we generated 8 test cases for validate size, so let's click on the first one. And what did we do? Since validate size takes an integer, we've seeded it with 1. And our next one is 0. So these are going to be the 1, 0, and probably -1 type scenarios or one-off situations. So those aren't particularly interesting. What is interesting is when we get to this next test case, which seeds it with a value of 99. And this is interesting because buff size is 100. So not only are we trying 0 and 1, but we also were intelligent enough to inspect this function and see that something occurs around the value of 100. So what happens? We try 99, we try 101, we try 100, and then finally we're going to try a maximum integer, a minimum integer, and -1. So we've covered all of our one-offs. We've covered values that occur around a condition that exists in the function under test. And so this is perfect if you're trying to do any kind of boundary or fuzz-like testing. And finally, let's take a peek at how we use stubbing in order to drive code coverage a little bit higher. I'm going to pick on a function called add timer, and we only have 83% code coverage here. And the reason being is we haven't entered into this else statement. And the reason why we haven't entered into this else statement is because query user always returns a valid record. So in order to modify the behavior of this function, we have to somehow control this function, query user, and make it return a false value in order to execute this line of code. And I want to do that in such a way that it doesn't impact my existing unit tests. So what I'm going to do is I'm going to create a stub for query user. If we go to my stubs view, I can find all of the different functions that are in use, including functions that exist in the standard C library. They can be stubbed as well. And I'm going to create a stub for this function. And again, this is just going to be regular C code. This stub gives me some instructions. I do have some things I need to do. The first is define the behavior that I want it to have when it is called. And so what I'm going to do is I'm going to implement this right before the first call here. And I want the value to be 0. Now that I've defined the situation where query user returns 0, now that I've implemented the actual behavior of the stub, I need to register it with the unit test case that will call the stubbed version. Before I can do that, I do need to add a new unit test because I want these 5 unit test cases to behave exactly the same as before. I want them to call the original query user, but I want a new one that will call the stubbed version. So we're going to duplicate this unit test. We'll call it test add timer 6. Let's go to this, and this will be my new one. I'm not going to change the behavior in here, but I am going to register the callback to use the stub. And so by simply pasting this macro into this unit test case, tells the Parasoft unit testing framework to use the stubbed version of query user, not the original. And so now, when I run this specific unit test case, and I go to my coverage, we'll see that now I have 100% code coverage. So far, we've automatically generated unit tests, and just now we duplicated an existing unit test, so we took advantage of the code that was previously generated for us. But there are other ways to generate unit tests. Namely, we can add them manually by using a wizard, so we can add a new test case using a wizard. And since we are focused on the test suite for timer C, it will show us all of the different functions that are available to be unit tested. And so picking on the validate size, we can call this one test validate size 9. We can provide a value to it. We can say 1,000 and specify the output as 8, which will not be valid input. This test will fail. And then we can finish. And you can see we have generated the test case code based on the inputs gathered through the wizard. If you don't want to automatically generate unit tests, if you don't want to duplicate the unit tests, or you don't want to use the wizard, you can always write this code manually. It is just C code. You just have to understand the way the Parasoft unit test framework works. And with that, we've covered quite a bit in Parasoft's C, C++ test solution. We've covered static analysis, we've covered code coverage, and we've covered unit testing and all the different ways to generate unit tests. And that will conclude the technical demonstration of Parasoft C, C++ test. We've shown static analysis, code coverage, and unit testing in a single solution. It's quite common that in order to get static analysis, code coverage, and unit testing, that could require up to 3 different tools and cost a significant amount. We take all 3 of those and provide those capabilities in a single tool, saving you time and money.